This is Scientific American's 60-Second Science. I'm Christopher Intagliata. Nearly 350 years ago, the Dutch scientist Antonie van Leeuwenhoek scraped some white stuff off his teeth, as thick as if it were batter, he wrote, and peered at it under one of his handmade microscopes. What he saw was alive. He described it as many very little living animalcules, very prettily a-moving, the biggest of which shot through the water or spittle like a pike does through the water. What he had discovered in the plaque from his teeth, the animalcules, that was bacteria. And before van Leeuwenhoek's observations of bacteria,
nobody could have discovered bacteria because they didn't have the optical resolution.
Lambert van Eyck is a materials scientist at the Delft University of Technology in the Netherlands. He says some of van Leeuwenhoek's microscopes could magnify things more than 200 times. And contemporaries like Robert Hooke in England, who'd written a book full of microscopic observations, they were stunned by his findings.
Robert Hooke actually spent quite some effort trying to discover why was Antonie van Leeuwenhoek so skilled and what kind of mysterious ways of producing the lenses made him able to see for the first time bacteria.
But van Leeuwenhoek wasn't eager to reveal the secrets behind the hundreds of microscopes he built.
Some people have explicitly asked him about the lenses, and he never said anything about it. It's still a big mystery how these lenses were made after 350 years. And the only way that they could discover would be to break it open, and then you would obviously see what the lens would be like, but they're too precious.
That's where Lambert van Eyck comes in. He and his colleagues were able to peer inside several of van Leeuwenhoek's microscopes with a non-destructive technique called neutron tomography. It's the same idea as a CT scan, but it uses neutrons instead of X-rays. And what they found surprised them. Instead of using lens types unknown to other scientists of his day, van Leeuwenhoek had just installed a common type of ground and polished lens in one of the microscopes they examined, and in the other, one of his most powerful scopes, he had used a globe-shaped lens produced by flame working, a lens type that his scientific competitor, Robert Hooke himself, had already described.
And so now the ironical thing is that actually, most likely, it's the method of Robert Hooke himself that Antonie van Leeuwenhoek used.
The findings are in the journal Science Advances. Van Eyck points out that van Leeuwenhoek was still an extremely skilled craftsman and glass grinder, able to build the finest microscopes of his day. And his discoveries of blood cells and sperm cells, parasites and bacteria, they were altogether extraordinary. It just seems the types of lenses he used to do that work were anything but. Thanks for listening. For Scientific American's 60-Second Science, I'm Christopher Intagliata.